What is NASA known for? What would most people say? The answer may not surprise you. Most would undoubtedly speak about NASA's past and present space flights and recent developments of new technologies and breakthroughs in science. While NASA does focus much of its efforts on projects that are outside of our home planet, much of NASA's research and development is performed closer to home. The first A in NASA stands for aeronautics, and that focus on aeronautics is just as strong today as it was in the past. Looking back to the early history of NASA and its predecessor agency, the NACA, much of the pioneering work in aeronautics was carried out by experimental aircraft that later became known as X-planes. X-planes are a series of United States aircraft and rockets used to test and evaluate new technologies and aerodynamic concepts. The X designator denotes the unique experimental research mission. For decades, these unique aircraft flew around California's high desert, pushing the envelope of flight mechanics and providing a solid foundation for our understanding of aeronautic principles to help solve major aviation challenges. X-planes and other prototype air vehicles hold a special place. They're a glimpse into the future of what supersonic aircraft and spacecraft may become. Over the last 7 decades, they've been a proving ground for developments, including delta wings, tailless aircraft, and supersonic flight. Vehicles that fly at supersonic speeds are flying faster than the speed of sound. The speed of sound is about 760 miles per hour at sea level. These speeds are referred to by Mach numbers. The Mach number is the ratio of the speed of the aircraft to the speed of sound at altitude. Flight that is faster than Mach 1 is supersonic. Supersonic includes speeds up to 5 times faster than the speed of sound, or Mach 5. From the first flight of the X-1 in 1947 all the way through X-plane flights in the early 80s, NASA and the military have built many X-planes that help challenge and change our understanding of aeronautics. Eventually, the emergence of advanced computing coupled with constrained budgets helped slow the development of full-scale X-planes and led more to the use of smaller, uncrewed aircraft for testing. But even with computer simulations and small unmanned aircraft proving to be powerful tools in the development of new aircraft, researchers understand that there is still a need for the development of full-scale, piloted X-planes to help close gaps in our understanding of aeronautic principles. The Lockheed Martin Skunk Works team, contracted by NASA, has built a new full-scale X-plane called the X-59. This new mission, called Quest, has 2 goals. First, design and build a unique shape that will reduce the loudness of a sonic boom reaching the ground to that of the sound of a closing car door. And second, once built and tested, fly over a number of U.S. communities to gather data on human responses to the sound generated during supersonic flight to make sure the noise is acceptable. NASA plans to hand over this valuable data from communities to federal and international regulators to help change the rules. If successful, this could lead to a new generation of commercial supersonic aircraft operating over land, clearing the way for time-saving, faster flights for the flying public. We will speak with researchers on the cutting edge of this technology to explain how this type of aircraft will be built and utilized, and how this aircraft has the potential to be the pathfinder for supersonic commercial aircraft of the future. And we will follow the X-59 team as they move from the testing and validation phase all the way up to the first test flight of this new X-plane. That sound is well known to military personnel and citizens who live close to certain military bases. But supersonic aircraft have been around for many years. In 1947, Chuck Yeager became the first person to fly faster than the speed of sound, around 760 miles per hour. Since that time, many military aircraft routinely fly past the speed of sound.
But soon after sonic booms became a regular thing, the military advanced very quickly to having supersonic capable aircraft. And then really very soon after that, we began to see the ideas for supersonic airliners. So it was really very exciting, and it really had a lot of possibility. But the military, where sonic boom first was kind of a novelty, it pretty rapidly became apparent that on a large-scale basis, the noise was just not going to be acceptable.
A sonic boom is heard after an aircraft breaks the sound barrier. And in fact, it can also be heard on the ground all along the path the airplane travels.
Well, basically, when you go above the speed of sound in an aircraft over land and even over water, you generate a sonic boom. So essentially what's happening is that the air just can't get out of the way fast enough of the airplane because it's going so fast. And so it generates a shock wave. And the shock wave propagates down to the ground, and it sounds like almost like an explosion or a loud boom, and it can startle people, it can rattle windows and cause problems. So for this reason, commercial supersonic flight is basically banned over land. Even military flights are restricted in certain areas because the shock waves can cause so much disturbance on the ground.
Up until about 20 years ago, there was one commercial aircraft that did not fly over land, but did operate at twice the speed of sound over the ocean between Europe and America. This supersonic jet was called the Concorde, and first arrived on the scene in 1969. The Concorde was so fast that a passenger could take off from Europe at sunset and outrace the sun in time to land in the United States to see the sunset again. Initially, it was believed that the Concorde could be used for overland flights as well, but that thought quickly changed with the realization that all the communities within the Concorde's flight path would be subjected to a sonic boom. So in 1973, the Federal Aviation Administration issued an order banning supersonic flight over land, leaving the Concorde to only fly over the ocean. Finally, in 2003, high expenses and limited flight routes forced British Airways to retire the aircraft for good. Fortunately, the decades of flights by the Concorde didn't go unnoticed.
And so with the Concorde, we learned a little bit more about sonic boom, and then we also learned a little bit more about some of the environmental challenges and the airport noise challenges that went along with that, and economic challenges and so on. The last flight of the Concorde, we really realized that we'd have to have a lower boom type configuration that would be more feasible for a commercial airplane.